buenas. Bienvenido a la sesión de los seminarios. Yo soy Maximilian Madile de Google España y tengo hoy aquí el honor de presentar a Chris Wetherell, un compañero de los Estados Unidos, y nos va a contar de Google Gear, más que todo, y también de Google Reader.
Okay. Hang on, I'll just wait just a second while people are getting settled. I know there's actually some more seats over here. And please forgive me, I don't speak Spanish, and that is a personal failing. I apologize. Okay. All right, I think we're almost all settled here. Ready? Okay, I think that's sufficient. All right, we'll begin. So hi, my name is Chris Wetherell, and I'm a software engineer at Google, and I work over in Mountain View, California in the United States. First of all, let me just thank the Google Madrid office, who have been great, and they've let me talk here today about something that I've been dying to talk about for months. And obviously I couldn't do so publicly, so first of all, I just want to let them know that I appreciate this a great deal. So what I'm going to talk about today, mainly, is Google Gears. Now, if you haven't heard of Google Gears yet, that's completely reasonable. Google Gears only went live as of, well, a few hours ago. So really, this is very inaugural for us. So my presentation is mainly going to be an introduction. I'm going to talk about the architecture and the API. And then afterwards, I can take questions. I probably can't take them on the podium, but I'll be wandering around just outside the hallway in case you have any questions about the platform or Gears or Reader or anything Google. Okay, so, oops, pardon me. All right, so what is Google Gears? First, hang on, I think someone's coming in. Hello, sorry. Google Gears is something we've created because we had needs as application developers, particularly as web application developers. And we've had a pretty significant investment in browser applications at Google, and in particular, browser applications with fairly rich interfaces. And we have toolkits that I personally believe are very nice in developing those interfaces, JavaScript for one. But traditionally, the browser has been considered an impoverished environment. There's stuff we've always wanted to do. And so we thought, what would be great is if we were application developers and we weren't even inside of Google, what would we want to see that would help us build web applications? And that's what we attempted to build, which is something that works cross-browser and delivers a series of features. Someone just stole my IP address. If you stole my IP address, give it back. We have a bunch of features that actually are part of Gears that have always been highly desired by us, and hopefully always highly desired by others. I want to talk a little bit about the platform's license. It's new BSD. That is pretty close to the public domain, which for your purposes, it means you can use it for commercial use or non-commercial use nearly any way you can see fit. We really wanted this to be as open a bit of code as we would desire outside of Google. So basically, it's going to enhance your browser. And why would we even want to do that? Well, here's why we'd want to do that. Traditionally, our user experience, while it's improving in the browser, still lacks. There's stuff we'd want to do. Have you ever done this? Have you had Gmail and Google Calendar and Google Reader and I don't know, any other application in 4 tabs at the same time. If you have, you're like me, and you've been pretty disappointed at the sluggishness of your browser. And one of the things we could help is with the user experience there, if there's some way we could help the browser be to avoid it being unresponsive. And there's also a pet project we've always wanted to have, which this handily delivers, is we've always wanted to have offline access to our data. Google's mission, which we take very seriously, is the world's information accessible to you wherever you'd like. And if we couldn't go offline before, then that wasn't very accessible, was it? So this is what we're going to try and accomplish here. Okay, there's a lot of people doing things in this space. It's a really exciting time, in fact, to be building very robust web applications. We thought we would just concentrate on where our domain expertise lies. We have a lot of investment in the browser. We know a lot about browser technologies. So we thought, if we know a lot about Ajax and the browser, why don't we start from that and then enhance the browser based on the code you would normally write in, say, an Ajax application? All right, so basically, 60,000-foot view. Here's what you would get with Gears. You get some sort of threading. I put threading in quotes here because it's not exactly threading. From a developer standpoint, what's important to know is that you pass a message, and it runs code in a protected space, not interfering with code in another space. And then we also wanted a way to get files stored locally, and we also wanted some sort of data storage, and a relational database seemed well understood, so that is also tied in. This is just a browser plugin. It's just an add-on, like a Firefox extension or an IE add-on. And that's all it is, really. It works for IE, works for Firefox, and all of its platform versions. You see the almost here for Safari. We're working on it. We love Apple. We love Apple. But we weren't able to get Safari support in for the release. So my apologies. So when you're going to do this and build applications like this, I want to, before I delve into stuff, just sort of prepare you, because these applications don't really look like the applications, or at least the applications that I'm used to building. Because they can store files locally, because they can have to manage deltas, have to manage changes in state on the front end, the whole application looks a little different. Here, look, since we're de-emphasizing the server, a lot less round trips, I'll show you kind of what that means. And please excuse how abstract this looks. This little yellow bar, XHR, is for the XML HTTP request object. Now, traditionally in Ajax, actually my friend Jesse came up with that term, Ajax, and so I like to use it as often as I can. Traditionally in an Ajax application, the UI, via XML HTTP request, talks to the server whenever it needs stuff. But in a Gears application, something's very different. We throw this database smack down in the middle of what was that stack. And that's pretty different. I mean, that has a very serious implication. That means we're not talking to the server as much. We have a lot of reliance on this database. In fact, that has big implications for the sort of traffic you normally see between your application and the server. Let me show you. This is the old web. That's an unfair pejorative. It's not old. It's still very much alive. But this is the way that a lot of applications used to be built. Anytime you needed a resource, whether it was an image or a file or anything, JavaScript, you'd have to go and request from the server, and you'd request it each time. And it was very noisy traffic. Now, Ajax kind of lessened the traffic on the server. It's interesting because as we begin to develop more strongly in a scripting language in the browser, some of the stuff that used to be computationally expensive no longer is. It is being taken care of within the front-end layer itself. You don't have to go to the server to make some computations. So then, in an Ajax application, we only go to the server when we have pretty serious data needs. Gears changes that a lot, and the server is a lot less important now. In a Gears application, how do I want to characterize this? Yeah, the server is forlorn. it sits there, waiting, earnestly, hoping that it will get a request, but we only care about it when we need it most. And most of the time, we don't care about it. And so one of the interesting results, if you look at this asymptotically, if you need the server less and less and less and less, well then, pretty soon, you don't need the server at all. And one of the nice bits about Gears then is that anyone can build offline applications using Gears. For those of you who don't know, you can go right now and download the software development kit at gears.google.com. And you can get started. You can build it right now. And there are demo applications within the SDK. They're great. I highly recommend looking through them. And that's about it. Wait, oh no, that's not entirely true. We thought it might be a good idea to make a bigger splash because, okay, this is for me. When I start an application and I'm developing in a new platform, I really like to see a real-world example, something that I can really sink my teeth into, somebody where they've solved larger problems, common problems, with actual users. And so we thought, hey, we should do that too. I mean, we should actually dog food our product. If you're not familiar with that term, it means that if you're making dog food, you should probably eat it. So we're going to eat our dog food. So now Google Reader now works offline. It works on a model that a lot of client applications work on. And you synchronize, you download your feed items, and then if you remove your internet access, yank your Ethernet cable, or remove your wireless, you can still read your items. I'd like to show you that actually right now. This is a Google Reader. I don't know if you've seen this before. It's a feed reader. I like to plug Google Reader. It was my 20% project at Google, and so it's a little bit of a child for me, and so I like to give it a little boost every time I get a chance. This is what Google Reader, it looks a little different if you've ever seen it. This is grayed out here, and there's a tiny little icon. In fact, maybe I can zoom in on that icon. Let's see if we can do that. Oh yeah, okay. So that icon, that didn't exist before. That's an icon which is telling me about my online or offline state. Right now I'm offline, actually. And Google Reader will perform as it did before. I'm just going to click on a series of things. I don't normally read this fast. Not even close. So what's happening here? And what's happening is it's requesting all of this data from the SQL database we have stored locally. You know, if you've ever used Reader before, you might have encountered something frustrating, which is that when you normally click on one of these links on the left-hand side, it's usually slow, and a loading icon pops up. It's very frustrating because, well, there's a lot of data we have to grab from the server. Remember that old model I showed you? You got to go, you got to fetch it, it's really slow. When you're offline, no loading icon. It's very fast. And this is one of the nice side effects of Gears. It's actually not really a side effect. We kind of intended it, which is that if you're building an application in which the database sits right in the middle of that stack, you can improve the latency of almost every request to a significant degree, to the degree which your computer is fast seeking files on its disk, and that's pretty good these days. And as Moore's law says, it's only going to get better. So let's see here. I may even have the internet right now, so let's see if I do. Oh yeah, okay, so now I'm back online. And what it did was all of the items that I read while I was offline, it synchronized those changes so that they are also read on the server, so that if I then use another computer or if I'm elsewhere, I always have my state around with me. And that makes it a much more useful application with that. Okay, so let me, we've seen that a little bit. I'm going to actually delve into the code now, into the API. For those of you who are non-developers, this part might be a little boring, and I apologize. If you want to describe the Gears API in three large bullets, then these are what they are. Local server for storing files, a database for storing data, and a worker pool for introducing threading, for lack of a better term, but introducing a way to keep your UI from blocking itself. Okay, so the first thing is this resource store. You give it a URL, and what it does is it downloads whatever the contents of that URL are, stores them in a local cache. This is great. In fact, if you were building, say, an offline email application, just to pick one off the top of my head, you might find this useful for attachments. You find out the URL of something, and then you download it locally, and then it's available whether you're on or offline. And that's very nice, actually. What we discovered pretty quickly when we were building actual applications is that an actual application has lots of resources, and it doesn't want to have to state them over and over again. So that's not very robust. We care about building applications. So we have a different kind of, we have a different kind of store. It's a managed resource store. And what this does is allows your application to create a file which describes itself, describes all the resources it's going to need, and then is versioned. And so that whenever an update occurs, Gears knows when to update itself. In fact, let's see here. Oh, it's, let me just go, and now I'm going to drill into code. Right here, you'll see our module. It's called beta.localserver, and it's versioned. This way, you can protect your application from compatibility differences that might break it when we update Gears. And then we give it a URL, and that URL is the location of the file which describes your application. And this is an example of that file. It's in JSON format. If you're not familiar with that, it's an object notation format that works very well with JavaScript because you can evaluate it, and then it turns into an object in which these strings become properties. And the strings following them become their values. If this version right here, let me highlight it, ever changes and is different at all from the last version that Gears stored, Gears knows to update itself, and then suddenly it will request all those resources again. So after we do that, let me show you what Reader's file for describing itself looks like. It's manifest. This is what it looks like. I know there's a lot of, well, we collapsed the white space, and there's a lot of resources. Maybe we should look into having fewer images. Okay, I'll add that to my to-do list. So then we get a new version every time we build Reader. And that way, Gears knows to update itself and keep current with all of our resources. All right, then we get all these feed items, and we need to store them someplace. So Gears has chosen SQLite. I don't know if you're familiar with it. It's great. It's very, very small and can store more than enough data for average use, gigabytes of storage capacity. And it has all the things that you would normally find in an SQL environment. I mean, if you're used to indexes, or you want transactions, or you want to store blob entities, then this will do all of those things. It has a strict security model, and I really want to get into this, which is that if you have two different URLs, and they differ either by protocol, by host, or by port, then one URL can't see the other's databases. So to be clear, if you go to foo.com:8000, and then you go to foo.com:8001, the latter cannot see the former's database. Just to be clear about that. I hope I did say that clearly enough. Okay, here's some database code. To those of you who have written SQL before, Some of this should look familiar. Look, there's a SQL statement. And yes, I know how weird it is to see a SQL statement embedded in JavaScript. It took me a few weeks to get used to that. In any case, we have a delicious table, and we're going to insert a burrito into it with a value of 5 because the burrito was delicious. And then the rest of it looks like, wow, almost every SQL code you may have ever written. You'll select some stuff, you'll iterate over a row, and then you'll inspect the row for whatever values you need out of it. And then you will close your result set. And then you will close your result set. And then you will close your results. The reason I said that 3 times is because it's incredibly important. I got caught on that maybe 1,000 times. So please, close your result set. OK. Oh, I keep doing that. OK. The last big part of Gears is the worker pool, which is threading. Basically, you're passing messages in strings. Each worker thread runs its own instance of JavaScript. It's completely protected. And so there's no way for them to interfere. They even can't reference each other's scope. So if you wanted, in fact, to use stuff you have in, say, a parent scope, you can't. This is good because this is protected that way. In fact, I probably should just show you that. It's much easier just to see. Here's some code which finds a next prime. And you guys are all developers, so you can just infer what you would write to find the next prime number. In fact, if you interviewed at Google within the last 2 years, someone may have asked you that. That doesn't happen anymore. And then you create a worker thread, and it runs in its protected space. So let's show what that really means to the browser. We're going to find some prime quadruplets. Prime quadruplets are a set of primes which have distinct distances between them. And they get computationally expensive pretty quickly. And so they're a nice example. And I'm aware of how nerdy all of that just sounded. So let's compute prime quadruplets the normal way. This is the way your browser would know. This is not the worker pool. This is just the way your browser would normally do it. Now, you'll notice it's pretty quick at the beginning. It's not going to remain quick. It's going to get pretty expensive right about here. Anyways, so now what I'm going to do is I'm going to try to tab through the browser as fast as I can. You might notice some lag. And the reason is that the browser is unhappy. It is single-threaded. It's trying to do something else. It would like nothing better than to ignore my requests to switch tabs. Oh, see, look at that. Ah, yeah, that's terrible. All right, let's stop that because it's doing horrible things to the browser. All right, now we're going to run this in a worker pool. This is actually within the threading model provided by Gears. And you'll notice it's incredibly responsive. It's not going to, it's running in a protected space. I can just do this all day. I can go farther than that and run a second one itself in another protected space. And I can still tab through the browser as fast as I can because, well, because they're running and not interfering with each other. In any case, that's one of the things that Gears can provide for you as a developer. All right, so once you have all these things, say you've got a database and you can store files locally, and you have a way to protect synchronization from harming your UI, then you have to figure out what offline means. This is really important. Gears does not help you determine what offline means. When we were doing it internally, we had several applications working at the same time, struggling to determine what offline meant, and we realized it was an individual choice. Sometimes an application thought, well, when a request fails, we're offline. And others thought, oh, no, we need it explicitly. And still others thought, oh, I only want a certain type of request to fail, but otherwise we're online. And others said, if it's too slow, if it's more than 3 seconds, we're offline. But if we're more than 10 seconds, we're offline. And it got very confusing. We realized that it was as individual choices as snowflakes. So Reader has its own choice. Here's what we use. the XML HTTP request object, which I talked about earlier. If it times out or fails, reader thinks it's offline. And the way we do that is we're using certain of these kinds of requests to ping the server. And we're using, for those who want the technical granularity, we're using head requests, except on IE6 because something bad happened, which I won't talk about because I'm nice. So then let's say you get that. You've figured out what connectivity is. Then you have to figure out what synchronization is. Actually, synchronization isn't obvious. I kind of thought it was. My coworkers, who are much, much smarter than I am, showed me how wrong I was to think that synchronization is sort of a solved problem. Right now, if you go to Reader and you synchronize, you have to explicitly choose to go offline. You have to click that little icon. You have to wait for all that stuff to download, and then you're offline. And then when you want to go back online, you have to click the thing, wait for all the stuff to synchronize, and then be back online. That's explicit, and it's manual. And if you leave with nothing here today, then what I'm about to say, just remember this part. The model that Reader is using today for offline synchronization is not the model we would encourage you to use. We did it for expediency. We want a proof of concept, and we want to remove the roadblock which exists. The roadblock which exists is that you can't read your feed items without this. And we want you to be able to read your feed items. But it's not in any way, shape, or form the ideal model. It should be automatic. It should be automatic. It should run in the background. It should be implicit. It should know which things you want offline, and it should be immediately responsive if your connection is lost. I would encourage you strongly, if you're building these applications, to do that model, to really concentrate on not having to force the user to understand what Gears is doing at all. That would actually be a much nicer world. I would like that. Okay, so that's it, kind of. There's one more thing, because every time we do something at Google and it doesn't have search, we get teased. People find us on the street, and then they harass us, and they sometimes beat us up. It's terrible. So we have search. I should have mentioned that this entire presentation is a Gears application. The entire thing is being served by an SQL database. I'm offline, and so yeah, this was easier. You could work on the plane, and I could modify slides. And I have to thank Aaron Boodman for, you don't know who he is, but he's great. He created Grease Monkey, and he works at Google, and he created this Gears application. It's fantastic. Anyways, if I went and clicked on this, sorry. If I went and clicked on this, then I would go straight to that slide, just to show you. So what this suggests is we actually have full text search. This is a joint project we have with SQLite. If you are interested in search technology, I highly recommend you check out this open source project. It's fantastic. Right now, it's called FTS, somewhat unimaginatively, for full text search. FTS2, which is what we're concentrating on, will deliver millions of documents for you to search. FTS3 is what we really are shooting for. Tens of millions of documents, but we don't really have that. My apologies. Pardon. We don't really have that yet. And we don't have multilingual search yet, but that's coming soon, probably, perhaps sooner than the tens of millions of documents. We'll see how quick we are. In any case, that's the entire scope of Gears. You can go to gears.google.com, download the SDK, or install a plugin. You can go to reader.google.com if you want to test it out in an application. That's about it. I'll be wandering around if you have questions. And thanks very much for your time.